So understanding the derivation of the formula, for that say we need to have the application of the concept of the differentiation. For that say I'm giving a small example to you like this. Suppose y is equal to 2 into x raised to 2 plus 5x plus 8. Suppose we are required to compute that say what is the differentiation of the in the value of the y with the change in the value of the x. Then in that case, say we used to have say some derivation like this, dy upon dx. How do you that is a compute the dy upon dx? It is 2 into 2 into x raised to 2 minus 1 plus 5 into 1 into x raised to 1 minus 1 plus 8 into 0 into x raised to 0 minus 1. We understand that say the with x say there is nothing in multiplication, so it is deemed that say in multiplication it is x raised to 0, because anything raised to 0 will become 1. That is the reason. So this is the way we have the differentiation. So we understand that say dy upon dx, that is change in the value of y with a change in the value of x, is equal to 2 into 2, that comes to 4. So it is 4 into x raised to 1 plus 5 into 1, that is 5, x raised to 0, so that will become 1, so plus 5, x raised to, that is say 0 is in, that is say multiplication, so any value into 0 will become 0. So finally we will have dy upon dx is equal to 4x plus 5. This is the way we can have the differentiation formula to be derived say based on this equation. Now understanding further, dear students, we understand that weight of x plus weight of y is always equal to 1. So we can say that the weight of y is equal to 1 minus weight of x. Okay. Now we know one more formula, something like this, that a minus b whole square. Then in that case you can simplify this equation, that is a minus b whole square is equal to a square minus 2ab plus b square. This is what we understand. So this is the way we have a small like the equation that we always do in our working. Now variance of the portfolio is equal to wx square sigma x square plus wy square sigma y square plus 2 into r into wx sigma x wy sigma y. Now I am rewriting the equation. I am assigning wy a variable as 1 minus wx. So sigma p square is equal to wx square sigma x square plus 1 minus wx raised to 2 into sigma y square plus 2 into r into wx into wy into sigma y into, now 2r into sigma x into wi into sigma y into this value I'm writing over here as 1 minus wi. Wx sigma x, wy sigma y into wy is 1 minus wx. So friends, over here what I have done, I have replaced the value of the wy with 1 minus wx. Remaining things as it is. I have replaced the value of the wy square as 1 minus wx raised to 2. This is the way I have done replacement. Okay. Next, against variance of the portfolio is equal to wx square sigma x square plus, now this entire value is multiplied with 1. So any value into 1 will remain same. So it is 2 into r into wx into sigma x into sigma y minus, again this entire value is multiplied with negative wx. So what will happen? Negative 2 into r into wx raised to 2 into sigma x into sigma y plus, now this 1 minus wx raised to 2. So it is a minus b whole square. So it is a square minus 2ab, that is 2 into wx plus b square, that is say plus wx raised to 2 into variance of y. Now rewriting the equation once again, variance of the portfolio is equal to wx square sigma x square 2 into r wx sigma x sigma y minus 2 into r wx square sigma x sigma y. Now 1 into this, so it will remain same. Then 2wx into this, so minus 2 wx variance y. Then wx square sigma x square, so plus wx raised to 2 into sigma y raised to 2. That is the way we can have the solution of this component of the equation. Only this component. Now we have to make the computation. What will be the, that is say the differentiation is required to be applied over here. That is say the change in the risk of the portfolio with say the change in weight of x. For that say we have to compute the, that is say we have to derive the, that is say the differentiation value. So for that say we can have something like this. So this 2 will be multiplied over here into wx raised to 2 minus 1 into sigma x square plus 2 into r into wx raised to 1. So into 1 into wx raised to 1 minus 1 into standard deviation x, standard deviation y minus 2 into r into 2 into wx raised to 2 minus 1 into sigma x sigma y plus, dear students, as we have discussed earlier, sigma y square only. So we have to understand it is like this: sigma y square into wx raised to 0, because any value raised to 0 will become 1, and anything into multiplied with 1 will remain the same value. So what will happen, it is variance of y into 0 into wx raised to 0 minus 1 minus 2 into 1 into wx raised to 1 minus 1 into variance of y, 2 into wx raised to 2 minus 1 into variance of y. This is the way we have the differentiation formula to be applied. Now dear students, importantly, in case of the minimum variance portfolio, there is an extreme value, so this is always a 0. That is by default in the formula, so this will become 0 for the minimum variance. So 0 is equal to, now 2 into wx raised to 1 into sigma x square plus 2 into r. Now this is wx raised to 0, and anything raised to 0 will become 1 into standard deviation x into standard deviation y minus 2 into, sorry, this 2 into 2, 4 into r into wx raised to 1, okay, 2 minus 1 is 1, into standard deviation x into standard deviation y plus this entire element will go down to 0, because anything multiplying with 0 will become 0, minus over here it is 2, it is wx raised to 0, anything raised to 0 will become 1 into variance of y plus 2wx, 2 minus 1 is 1, so it is 2 into wx into variance of y. Now we understand that, say, the entire equation can be multiplied with 1 by 2, entire equation. So this is 0 is equal to, it is wx sigma x square, okay. Then we understand that, say, this will become r into standard deviation x standard deviation y minus, this will be 2 into r into wx into sigma x into sigma y. This is minus variance y. This is plus wx variance y. In a way that the entire equation is multiplied with 1 by 2. 1 by 2. Now friends, what we will do? This wx sigma x square, I keep it over here. Wx sigma x square. Then minus 2r wx sigma y. Wx sigma x sigma y. So minus 2 into r into wx sigma x sigma y. Then this plus wx sigma y square. So all those things are kept over here only. And this two value is transferred on the opposite side. So it is the variance of y will become positive minus r into standard deviation of x into standard deviation of y. This will become negative. Now in this equation, I am taking wx as common. So in bracket we will have variance of x plus variance of y minus 2 into r into standard deviation of x, standard deviation y. That is, over here we understand. So this is wx, this is wx, and this is wx. It is taken common, is equal to variance of y minus r into standard deviation of x, standard deviation of y. Now weight of x will be equal to variance of y minus r into standard deviation of x into standard deviation of y divided by variance of x plus variance of y minus 2 into r into standard deviation of x into standard deviation of y. This is the way the wx can be calculated. So let us have understanding of the derivation of the formula. A summary. Basically, this is based on the concept that we have of the differentiation. That is, what will be the change in value of one variable with the change in the other variable is what we understand is the differentiation concept. So for that, I have explained you with a simple example. If at all y is equal to 2 into x raised to 2 plus 5x plus 8, it means that it is 8 into x raised to 0, because anything raised to 0 becomes 1. So dy upon dx is equal to, technically it is called, it is n into x raised to n minus 1. That is the differentiation. So 2 into 2 into x raised to 2 minus 1. 5x, so it is 5 into 1 into x raised to 1 minus 0. Then it is 8, so it is 8 into 0 into x raised to 0 minus 1. So dy upon dx is equal to 4x raised to 1 plus 5 plus 0. So dy upon dx is equal to 4x plus 5. Wx plus wy is equal to 1. So wy is equal to 1 minus wx. Then we know that the a minus b whole square is equal to a square minus 2ab plus b square. So sigma p square is equal to wx square sigma x square, wy square sigma y square plus 2r into wx sigma x, wy sigma y. Variance of the portfolio, exactly the same thing I have written once again, with the only thing that's what I have done, wy is replaced with 1 minus wx. Wy square is replaced with 1 minus wx raised to 2. Then we have done only the simplification. 2 into r into wx sigma x sigma y. That entire value is multiplied with 1, so it will become as it is. This entire value into wx, so it will become 2 into r into wx square into sigma x sigma y. 1 minus wx raised to 2, that is a minus b whole square, a square minus 2ab plus b square. So it is 1 minus 2 into 1 into wx plus wx square. This into sigma y square. That is the way we have the multiplication. So sigma y square into 1 will become sigma y square minus 2 wx sigma y square, then wx square sigma y square. That is the way we just open the bracket, nothing else. Now the important, like the value comes, that is the differentiation. What is the change in the risk of the portfolio with the change in the weight of x? That is the way we have the differentiation equation to be formed. So change in sigma p square divided by change in wx is equal to, what we have done over here, so this is taken 2 over here into wx raised to 2 minus 1. Over here it is wx means wx raised to 1. So 1 is kept over here and wx raised to 1 minus 1 and so on. Important difference, this value will be 0 in case of the minimum variance portfolio derivation. Whole into 1 by 2 just to have the simplified value. Then keeping all the value of the wx on one side and the remaining on the left hand side. Then wx is taken common. Rest all of them say are kept in a bracket, and with that say finally we have this simple derivation. And dear students, this is also what we understand is nothing else but it is the covariance between x and y. This is nothing else but it is the covariance between x and y. This is what we understand.